Hello and welcome to Lube Tech. My name is Corey Vanderbosch. I'm the plant manager for our northern operations. At Lube Tech, we offer lubricants, chemicals, and services for automotive, fleet, manufacturing, and we offer custom branded OEM support for lubricants. So this is our receiving and shipping area. It's where all of our packaged materials come in, so our packaged fluids as well as our packaging materials. They all come in through these dock doors. This site does not store any finished goods, and so all of our finished goods come right off of our packaging lines and go right onto trucks through these dock doors and out to our distribution center. From here, raw materials will be received in, put into racks, stored until they're ready to be used in manufacturing. All right, we're going to walk out to our bulk receiving pad right now. Dan, can you talk to us about what you're doing today?
Transport came in, just got the approval from the lab after sending up the sample, and I'm hooking it up and getting it in the building.
Awesome. Thanks, Dan. Yep. So what Dan's doing, he first took a sample out of this transport, sent it up to the lab, they approved it. Now he's hooking up and is going to pump it into the building into one of our storage tanks. What are you pumping off, Dan?
This is ADNOC 8.
ADNOC 8. So it's a base oil, so it's pretty common material, commodity material, but once we mix that with some of our proprietary additives, then it'll be a high performance fluid ready to go out to the market. They refine it in Abu Dhabi, put it on a large barge ship, comes across the ocean, gets unloaded in New Orleans, and from New Orleans they take it out of their tank and they put it onto rail cars or transports and then ship that across the United States to us. So barrel of crude, a lot of people look at it as something that you turn into gasoline, but really gasoline's a very small part of a barrel of crude oil. That gets broken into gasoline, diesel fuel, asphalt, base oils for us, other types of paraffins, waxes that get all kinds of industrial uses. There's a lot of uses for that barrel of oil. So off of the truck goes through a hose into each of these dedicated lines. So we deal with a lot of different chemistries at Lube Tech. And we want to make sure we try and keep those chemistries as dedicated as possible to make sure that we don't have any contamination which might affect the performance of the fluid. So a unique thing that we utilize at Lube Tech is pigging. Pigging system basically squeegees down the line after we're done pumping to make sure we totally clean it out. There's a little unit in there called a pig. We'll show you one of those in a little bit. That pig gets shot through the line, squeezes it out through air pressure. So these two valves do different things with the air. One valve shoots air into it, fires that pig to its destination. The other is a demist line which relieves the pressure as we fire that pig back. And then we utilize dry lock fittings wherever we can to make sure that we don't have leaks at our connection points. These fittings are special in that they have a spring-loaded mechanism behind them. This plate actually goes backwards and allows fluid to come in or out, and then once we unhook the line, that spring mechanism pulls the plate forward and seals the valve so that we don't have any drips or leakage. Some of these products that we bring in are very thick, and in the winter in Minnesota when the product comes in and the air temperature is -10, that fluid's -10 and makes it thick as molasses. You've heard the term thick as molasses in the wintertime. Well, this stuff's thicker than molasses, and so in order to pump it, we have to heat it up. So it might take 2-3 days of heating with steam before we're able to pump that product into the building. After a couple of days of steam, that product will get up to 40, 50, 60 degrees, and it'll be much more pumpable, and we'll be able to move it much more quickly into our building. Steam's an efficient way of heating products in industry. If you look at the different ways to heat, you have electrical, steam, or direct flame from natural gas. Direct flame from natural gas is both expensive because you have heat loss, as well as dangerous because you have open flame and gas pipes running through your building. Steam is much safer in that it doesn't have the fuel running through your building, it's just steam. Now there are still some hazards with it, especially more with high pressure steam than low, but that steam is very hot and can burn you. There's a lot of energy in it, and so we want to make sure that our employees are using proper PPE when using the steam. These rail cars are bulk fluid rail cars. They store approximately 22,000 gallons. We use these to bring up our raw materials, mostly from the Gulf, but we also get them from the coast as well. Some of them from as far away as Abu Dhabi in South Korea. So to travel a long ways cost effectively, we load them into these large rail cars to move them across the United States. So let's move on to blending, and we'll see what we can find. We'll see where these oils wind up and where they get turned into something new. Watch your step here. There's a trip hazard. All right, so this is one of our blending vessels. So in this vessel, we take different components. So if you think of oil, it's like Kool-Aid. There's 3 key ingredients. First, you have your base oil, which is like the water. It's pretty neutral until you add other stuff to it. Then you have your additive, which is the secret stuff. It's the Kool-Aid mixture. And then you've got a few other components, which we can call the sugar, like a viscosity modifier, other additives that we add to the oil to make it do what it needs to do. So, like making Kool-Aid, we add all those ingredients together and we mix it up. We then add heat to make sure that that goes into a full solution. Mix it, and then once it's fully mixed, we send a sample up to our lab. So we have 3 kettles up here, a 2,500 gallon kettle, a 6,500 gallon kettle, and a 1,500 gallon kettle. The 1,500 gallon kettle is where we do our metalworking fluids. We do metalworking fluids in a separate kettle because if the metalworking fluids were mixed in with an engine oil, it would be very detrimental to the engine. And same thing with the cutting fluids. If there's engine oil in the cutting fluids, it would affect the performance of machining and machine shops. So we keep those separate to make sure that we don't have any contamination. So there's pipes in the building. They run the product from our bulk storage tanks up to our production kettles. They also run from our offload points into the tanks. So we use pipes to move the fluid throughout the facility to be as efficient as possible. Just watch your step. The floor is a little bit oily. So being an oil plant, we do wind up with oil on the floor, but we're taking whatever measures we can to keep our team members safe. We've added these stainless steel drip pans underneath areas where we tend to see common leakage. That keeps the oil up off the floor and makes it easy to clean, as well as protects our employees. So this is the bottom of our 6,500 gallon kettle. These manifolds have all our bulk raw materials piped into them. This is a little bit of an old school system where it actually takes an employee by hand turning each one of these valves individually, setting the meter manually based on a work ticket that tells them how much of each component to add. So they'll turn the valve, pump one product in, shut the valve, pump the next product in, and go through that process through the entire recipe. Once they're done, they'll mix that product for a given amount of time with heat, and then they'll take a sample and send that up to our lab. This is where we sample the product. It's on an automatic valve to make sure that it can't accidentally be left open. An employee will open up this valve, let a little bit out, make sure that the port's flushed, and then take a sample, a 1 pint sample, and send it up to our lab to do full QC analysis to make sure that we give our customers the assurance they need that their products are going to perform the way that we intend them to. So this is our bulk storage area. We have about 800,000 gallons of storage on site for bulk raw materials, bulk materials. These materials come in by either rail or by transport. The rail cars we bring in are approximately 22,000 gallons. The bulk trucks we bring in are 6,500 gallons and can come in either as one product, or sometimes we can have a split truck that'll have multiple products on it, up to 3. All right, so out of our blending kettles, once we've been approved by QC, all the product gets pumped up through this manifold. So you'll see a connection point for our 2,500 gallon manifold that we were standing on top of earlier. And it gets pushed over into one of our process tanks. From our process tanks, that oil can go into drums, totes, 1 gallon packages, quarts, any package size down to 2.6 ounces. We put them in process tanks in order to provide a buffer between our packaging lines and blending to make sure that we're able to go from job to job on our packaging lines without shutting down due to blending issues. All right, Chris, can you tell us what you're doing here today?
We're pumping up a product from the little kettle, pumping up 10W50, goes through the manifold, check for leaks. We put what product we're pumping up right here so people know. And we also put a tag, that way people can double check what's in here and what they're doing.
All right, thanks, Chris. So now that we've got the product properly labeled in our process tank, now when a line's ready to change over, they'll come over, take their work ticket, compare it to the tank, and make sure they have the right part number and lot number on that order. From there, they'll go and hook up to our process tank manifold, where they'll hook up some piping in order to make sure that that product gets over to their line properly. All of our products out of the process tanks go through a 25 micron sock filter. That makes sure that we capture any dirt or foreign material that may have been picked up somewhere in our system or may have come from the refinery, to make sure that we have the cleanest oil possible going into the bottles. We formulate for our OEMs, which is a unique value proposition for us. So not only do we have the ability to blend and package, but we also have the research and development arm, which we'll see later, which is able to come up with brand new innovations in lubricants in order to formulate for our customers. Once they do that formulation, we have a engine test center where we're able to perform engine tests, make sure we dial in that formulation so that we get the perfect amount of performance for that fluid. We then go to our customers, they validate that, and once it's validated, we can start putting that into bottles. Move on to our packaging lines. Now that we got the fluid hooked up and ready to go, take a look at two different lines that do different things. We'll start over on line one. Line one packages gallon size bottles and 2.5 gallon size bottles. Our oil comes into this tank on top of the packaging line. That allows us to get consistent flow into the bottles. The bottles are filled based on a time and pressure system. So based on a certain timer in our PLC, these valve heads stay open to get the right amount of fluid into the bottle. So in order to measure our efficiencies and let our operators know how they're doing throughout the day, we have these boards made by Vorn that measure our OEE. Our OEE is our overall equipment effectiveness. It measures our quality, it measures our performance, and it measures our downtime. And if you look right now, we're only running at 18 bottles per minute. That's a performance loss. So we want to make sure that we're trying to solve the problems hour by hour to make sure that we're running as efficiently as possible. So once the bottle's filled with oil, we put a cap on the bottle. That cap does two things for us. One, it seals the bottle so that we don't have leakage in transit. And second thing is it gives us a tamper evidence seal. That tamper evidence seal makes sure that this product gets to the customer the way we intend it to. So each of these caps has that foil seal in there, and that's bonded with a thin layer of adhesive between a fiber backer board, which is permanently adhered to the cap. And when this goes through our induction sealer, think of an induction sealer like a microwave. It heats up that foil, melting the adhesive on the backing, separating it from the cap, as well as heating up an adhesive on the bottom side that you see here, melting that adhesive so that that seal sticks to the cap. You take a look here, we can see that that foil seal is now permanently adhered to the bottle, which is why we need to puncture it in order to open it up. That gives us our tamper evidence. And then we can see on the cap the fiber backer that's behind that foil before it goes through the induction sealer. Once we come out of our induction sealer, we go through a weight checker. That weight checker lets us know that every single bottle is being produced with the right amount of fluid in it. If that bottle doesn't have the right amount of fluid in it, we reject it off the line with our rejection arm. Along with the QC verification to make sure that every bottle is correct, the check weigher actually feeds information back into our PLC, which tells the PLC, do I need to make an adjustment to the program to make sure that we get the right amount of oil in. That takes the operator out of the equation from having to control the fill weights. Now that we have the bottle capped, weighed, we add a label to it. That label identifies the product. Proper labeling is one of the most critical things we do, because even if we have the fluid perfect, the bottle's the perfect weight, and the cap is on so that it doesn't leak, we need to know that we have the right fluid in the bottle. Otherwise, if the customer uses the wrong fluid in the wrong application, they could have an issue with their engine. So now that we got the label on, we want to make sure we have the right label. Because again, if we put the wrong label onto a bottle, it could be used in the wrong application, and that could do damage to our consumers or customers' engines. So in order to make sure we do that, beyond our other quality processes, we check every single bottle using our vision system. Our vision system is a series of cameras that look at the front and back label and then evaluate it against a program to determine if the right label's on the bottle. On the back label, we're looking at a barcode. If that barcode's right, we know we have the right back label on. On the front label, we don't have a barcode to go off of, so we're looking at 4 different unique features on that label, knowing that if we get those 4 features correct, we're going to have the right label on the bottle. Last step in the process, taking the bottles off the line, putting them in cases. From the cases, we'll put them onto a pallet and ship them over to our distribution center. How you doing, Ka?
Good, how are you?
This is Ka. Ka's our second shift supervisor. Ka, can you tell us a little bit about what your day looks like?
Well, my day, I start out by coming in here, getting my shift scheduled ready for my crew so everybody knows where they're doing for the day. Also overview work orders that are printed, raw materials, so that we don't have any shortage or any downtime throughout the night that we're going to be running. After all that's done, I float around, monitor my lines, make sure everything's running smoothly, and help out where help is needed throughout the whole night to maintain the good efficiency out here on the plant floor.
Thanks, Ka.
Yeah.
All right, from here we'll go take a look at the lab. A little quiet day today. We'll see if we can find somebody to walk us around. This is Mike Quigley.
Hey guys,
This is one of our research and development chemists at Lube.
welcome to the Golden Valley Lab. This is our corporate lab at Lube. We have 3 main functions: research and development, quality control, and condition monitoring. So we employ 8 to 10 chemists making new fluids for our customers. So we're working with engineers at a company who builds a motorcycle or an ATV or a wave runner or watercraft. We'll develop a fluid specifically for that type of unit, and then we'll manufacture it and then sell it to the customer. So we spend a significant amount of time in our engine lab taking the engines from those units and developing chemistries and tuning them into what those engines need. And then we'll make them here in our plant. We run 20 hours a day, and we have chemists staffed quality controlling those for 20 hours a day as well. So anytime we're making something, we're testing something. We also then, once we put that fluid into the field, we'll then get samples back, and then we'll actually see how it's doing in the kind of like a blood test check. How is it running in the actual unit? And we'll do that on site in our engine lab as we're developing fluids, and then also see Joey's working on a batch right now of samples that came in from the field, and we'll give them reports back to say yes, that you're good, or no, there's some problems here and we need to adjust. So Ton's hard at work over here. He's going through all the materials that come in. We test them to make sure they're in specification. All of the blends or mixtures we make, every time we make them, we're making sure that they're accurate and in specification. And anything we package, before we put it in a bottle, we test it. In the middle way through, we test it, and then as it goes out the door, we test it. So we put a lot of energy into making sure what we're putting in the bottle is the right thing. We're testing for things like viscosity, elemental analysis, and then molecular analysis. So bulk viscosity, how thick or thin is it? If you could feel these, they're warm, and so fluids thin out and thicken up at different temperatures. And so we're testing at this specific temperature, how thick or thin is the fluid, and at the higher temperature, how thick or thin is it. We're testing for contamination by water. Elementally, we're kind of looking into the fluid. So this is an ICP. We're looking at atomically in the fluid how many zinc atoms, how many phosphorus atoms are actually in there, and we put in a certain amount to have the fluid have a certain performance, and so we can test how much is in there, how much did get diluted out, or that kind of thing. So we walked over to the engine lab. This is where we take all the hard work we did in the fluid lab and start to apply it to the real world. So now we're further along in the product development process, and we're taking fluids and actually running them engines and then testing it along the way to see how it's doing in the engine, or the lifeblood of the fluid or the engine.
Heading into the test lab. So the test lab is a secure facility. We're trying to keep out as much as possible due to the amount of trade secret we keep in here. But we've got special permission here today to shoot a few very small segments of what we do to try and show you how cool it is to test an engine.
Here, this will cycle back and forth. So if you stand here, you can kind of get a shot of the engines going up and down. So this is a dyno lab, has 4 individual cells. We can test up to 1,000 horsepower engines if need be. This cell here has temperature control, so we can adjust the climate. And this is for typically smaller engines that need a little bit tighter tolerance on the environmental controls. Right now we're testing lawn and garden kind of whips on several different formulations to see which of them has the best performance in that application. A lot of times we will run them until they stop. Most often there's a preset program that then we run a certain amount of hours, and then we pull them down and see how do the internals look, or how does a particular component look. So the problem with running it till it dies is then a lot of times the engine is destroyed. You can't tell a little bit about how it was getting there. If you got a bunch of pieces on the table, it's hard to walk back and see how did it die if it's already exploded. So we try to go harsh, but not all the way to failure. We've got a couple different engine tests set up here. This is a Honda test we use for lawn and garden fluids. So these are 25 horsepower, 800 cc, something you'd find on a commercial grade mower. And so we're running our lawn and garden fluids through these. We run a test, then we come over here, and then we tear it down and inspect the parts to see how it did in the actual test. We also have a Jazzo 2-stroke test stand. This is an industry standard test, and so we will run this test in order to certify that our fluids meet a certain specification. And over here is kind of like the operating table. Once the engine's run, they'll get torn apart, rated, photoed, and the report put together and presented to the customer or to the formulating team to see how things went. Right here we're developing a new snowmobile engine oil, and so we have the engine out of the unit, and we're going to run the new fluid on there and make sure that it performs better than the old fluid.